You're in Boulder, right? Or Colorado?
Yeah, Colorado. I'm just technically working from home, which is about 20 so miles east of the office.
I see. Okay. Feeling better?
Yes. There was a message from Forrest in the Slack. He's running a little behind. He's in another meeting and it's taking longer than he thought it would.
He's in another meeting at 6 a.m.
Yeah.
Goodness me. All right. Well, there any questions anybody has? I'm happy to try to answer them. I see Emery's here, so he can also contribute. I ran through the TopSap notebook myself yesterday and seemed to do well. And all the way through. But I haven't actually tried whatever the assignment was for homework. I guess it was to get your own scenes and see if you could do it with a different set of data. I haven't done that myself. Anybody have any difficulties?
Good morning. Well, I have a question. It's not from yesterday. It's from the first day, from the modeling, the Mugi model. Okay. So can I share my screen?
Please.
Okay. So I tried to mimic the model, sorry, the grid search, this one for the X and Y. So I tried to mimic this here, and here I stated the range. Here the X and Y are kind of constant. And this is the result I got. I found that here the Z is changing, but the volume is not changing.
Yes, that is a bug in the script. So you see the print statement there that says print. Print that one.
Yeah,
Just
this one.
indent that one step further. Just hit, go to the P at print. Click your cursor there.
Here?
At the P, yeah. Just click on, yeah, there you go. Oops. Get rid of that. I think you just click someplace else.
Okay.
There you go. There you go. So now at the P, are you holding down the shift key or something?
No, I'm not. Actually, this is just, I'm just clicking. Right, this is a right click on the P. This is a right click on the P.
Yeah, don't do
not right click.
Left click. Left click.
Okay, left click on the P. Okay.
Yeah, I just on the other side of the P, left side. Go to the front of the P, before the P.
Okay.
Not after the P. Okay, and then just go right next to the P. There you go. Now hit tab.
Okay. Tab.
There you go. So now it is indented properly. If you rerun that cell, you'll see both of them.
Yeah, I need to run. Okay.
It's to rerun the notebook, I guess.
Yeah, I'll try to do something else. 1 second. Share screen. Let me get the other one. Yeah.
Yeah, I don't know why the indentation was done that way, but it's a double loop. So if you want to see both things updating, the print has to be indented to the level of the second loop, the inner loop.
Yes, but this is a correct way to do it, like stating the range and everything. So
Yeah.
no problem with this.
Assuming you made all the right changes in the code below, yes, that looks correct.
Okay, great.
So
Thank you.
even with that print statement, having an error or having the wrong indentation, your misfit calculation should be correct, and your error surface should be correct if you have correct sampling. So maybe you could show us what your error surface looks like.
Yeah, I think I need to run the code from here. Yes, the libraries, they weren't imported. Okay, everything. I think I just need to run everything.
Yeah, so just click on the double arrow at the top next to the word code.
Yeah.
Yeah, that just restarts the kernel and reruns the whole notebook.
Oh, yeah.
That's
Okay.
always the safest thing to do from my perspective. It takes a little longer because you run everything, but this notebook stuff.
Yeah. Just downloading. This is.
It's already past that since the numbers now show up. So keep going down until you see the star in the.
Yeah. Okay.
Doing good, doing well.
And so far, so good. Okay.
Okay, so now it's right there, doing your misfit. That's the plotting. So I think if you go up a bit, you should be able to see your numbers changing.
Yeah, here. Yes.
Oh, this one is the, that's not your exercise. This is the example in class. I think this one has
Yes.
indentation also. So you'd want to go back and fix that.
Yeah, the other one. Oh, okay. So I'll check the one.
Yeah, just check your homework.
Yeah, the one I have just changed.
See, now they're
Yeah,
both changing.
Yeah, it's working. It's working now.
Yeah,
So
so let's see your
yeah.
misfit function.
Yeah.
Oh, it's still calculating.
But I think for changing the best fitting model, it just yeah, it only took the first value in the range here and there. So this one is no problem in here, right?
It looks right. Yeah. But maybe you forgot to change something else.
Yeah, probably. So
CS.
something wrong would be here, I think, with the Z and volume. So change.
You didn't, in the displacement data for Mogi function, did you change the order of X and Z and V, or were they always in that order? X, Y, Z, and V. See 3 lines up.
Okay.
Let me see if I can. I don't know if any of the other instructors are seeing what's going on here.
I think it's the same
I
order.
think you have it flipped. The order of the arguments to displacement data from Mogi should be X, Y, Z, then volume.
That's what I remembered, but I don't have it up right now.
This one, okay. Like this?
In the actual call to the function, so inside the for loop,
Okay.
where you have predicted displacement map equals displacement data from Mogi.
Yes.
Yeah, so you up one line, you have Z and then volume and then X, then Y. It should be X, like XS, comma, YS, comma, ZS, bracket K, comma, volume, bracket L.
Okay.
And so the way you know that is if you go up to the example of this problem, you'll see the order would be XS with the XS, YS, and then Z and B. So you can't change that order because you're calling a function that has specific.
Yeah, it's here. Yes.
Yeah, there you go.
Yeah.
So
Okay. Let me run.
that should help.
Let's see. Okay. Yeah. This is different. It's working now, I think.
Yeah,
Yeah. Thank you.
now you can change the misfit function. And then
Great.
good. Good.
Thank you.
Welcome. What's next? Any questions? Anybody try the TopSap notebook with different data? Nothing?
Don't be shy. Feel free to unmute and turn on your cameras. Ask questions in the chat.
Yeah, presumably you're here because you have questions. Or maybe you're hoping somebody else has questions. Anything on the theory, anything on the pre-course, your netrc file, is everybody has their netrc file set up properly? All of their license agreements set up properly with ASF? What time of the day is it for everyone? It's 7 a.m. here in California. And Forrest, you already had a meeting at 6 in the morning in Alaska?
Well, I'm in Des Moines, so
Ah.
9 a.m. for me here.
I see, okay.
Yeah, so it's a little early.
I was wondering, I mean,
Yeah, I try not to schedule 6 a.m. meetings if I can avoid it.
me too. 7 a.m. is hard enough,
Yes.
but I imagine others on this call are in the middle of the night.
Mhm.
Yes, and this is at 8 a.m., 9 a.m. So far we have a continuous stream across the country.
I have a theory question for you, Paul, if nobody else is going to jump in,
Yeah, go for it.
which is, I think either you or Eric mentioned a little bit about how you could use ionosphere corrections to start calculating azimuth offsets for TOPS Sentinel-1 data as opposed or in addition to ESD. Would you be willing to talk a little bit about that?
I don't know exactly what I didn't mention that.
Okay,
I
that was
don't
Eric.
know exactly what he was referring to, but what one can do is if you use the split spectrum method to calculate the ionospheric correction using range data, then you get a phase screen, which basically you get a phase function, two-dimensional phase function, which you can differentiate in the along track dimension. And the azimuth offset that you get from ionospheric propagation delay is basically proportional to the gradient in that along track dimension. So assuming the estimate is not too noisy, which sometimes it is, you can take that gradient, use that to basically calculate what the azimuth offset is and then make the correction for that. In fact, I think that is what they're planning to do for some of the opera processor so that they can avoid the ESD step. It's less time consuming to do that. Does that answer your question?
Yes, it does. I've been thinking about it in context of, ASF, and my team is trying to look at what would it look like to be able to deliver somebody a single burst interferogram. And if you apply ESD, you need to load in multiple bursts around the burst you're interested in. And just kind of curious about how that alternative where you're only using the split range spectrum data from one burst. We couldn't. Go ahead.
I was just going to say that might be a challenge because the burst has limited extent. I don't know exactly how big they are, but what are they, 20 kilometers in the long track dimension or more?
I think that's about right.
Yeah, so often in order to get a good estimate of the ionospheric phase, you have to basically average, smooth the data to that level. So have much of a gradient over a 20 kilometer spacing. So it might be difficult to use that for a single burst. We're looking for NISAR, we're looking at whether 5 kilometers or 20 kilometers, what the right scale length is for the smoothing to get the noise down low enough to get a reasonable estimate. But I think for noisy data, 20 kilometers is fairly typical. So you may not be able to avoid multiple bursts in doing robust ionospheric correction for a long track.
Yeah. And, I think that won't be too bad because, we still don't have to pull in the entire SLC to do that correction for a burst. So. Well, it looks like we got a question in the chat.
Yeah, so NISAR will have mostly when S-band is turned on. I'll talk more about this on Friday in the NISAR lecture, but when the S-band radar is operating, almost always the L-band radar will be operating simultaneously. So there'll be joint L and S band observations. They can, of course, operate separately. Most of the world will be L band only. There'll be a few places that will be S band only, but over all of India and the surrounding regions of India, surrounding countries and ocean, as well as large parts of Antarctica and a few other places around the world, the joint L and S band operations will be taken, and that will be a huge resource. It won't be global, but it will be a large resource for people to use. You're welcome.
Will that be the first time we have data taken at the exact same time, but at different SAR wavelengths?
Not the first time. It depends on what you mean by the first time, but the ISCE mission, which flew in the 90s, had C-band, L-band, and X-band
Oh,
all at the same time, but those were taken over 2 10-day periods, separated by 6 months. So ISCE was a real pioneering mission in many ways. It had the first ScanSAR, it had the first multi-frequency, it had the first fully polarimetric observations. It did displaced space center, long track interferometry. It did spotlighting, and it did another thing. Oh, it did repeat pass interferometry at multiple wavelengths. Many of those observations were used as the basis for justifying SRTM.
mhm.
They were able to fly the shuttle to within 100 meters or so at certain places around the world in repeat pass. And you could see very clearly the topo, that you could get reasonable topo with that system. It was also a super powerful, low altitude and very high power transmitter. So the signal to noise ratio was amazing, better than almost all spaceborne systems. So it really provided a great reference data set for all kinds of studies.
Mhm.
All the data is up at Alaska processed.
Yeah, I'll have to check some of it out. I don't think I've ever looked at the ISCE data.
It's really beautiful data. I processed a very long strip over California, over Long Valley, the Mammoth Mountain area, all of California, 2,000 kilometers. I made a topo map of that. Also processed New Zealand with these were 1-day repeat interferograms, basically. Also made some 6-month repeat interferograms of both L and S band, showing quite explicitly the difference between correlation at L band and C band over different types of terrain.
Oh, that's really interesting.
Yeah, I wrote a paper on that in '96. That is, I'd say, kind of a standard reference for that kind of thing. Plus, at least when I talk about it, that's my reference. And it also shows hints of differential dispersion effects. So, for example, ionospheric effects are dispersive. The different wavelengths in the radar band behave differently. They have different path delays that are not proportional to the wavelength directly. And even though ISCE was flying below the sensible ionosphere, you can see localized dispersion effects in certain parts of these images in the Hawaii case that I was processing. I think they were related to surface scattering phenomena that were dispersive to the C-band and L-band had different scattering properties. So it's it shows that, you know, wavelength does matter, even for surface scattering. Those, of course, are much wider band separation than just what you get within one radar band. But if you had ionospheric effects, having those two frequencies should be a much better estimate of, give you a much better estimate of the ionosphere. So if we had S-band and L-band globally for an ISAR, then the ionosphere could probably just be stripped out with no problem.
I just posted the link to what I believe is the paper you were talking about in chat, in case others are interested.
That's it.
Hello.
Yes.
Yes. Okay, I have a question. I will share my screen.
Sure.
Okay. Okay. You see my screen, right?
Yes.
Yep.
Yeah. Yeah. Okay. This is a copy for the top set. I tried to download another scenes. So sorry. Here I downloaded new images, and after that I downloaded the orbit files for those images. But here in quick overview, I think there's something wrong because it's still searching for the old images.
Oh,
So yeah.
did you change that? You probably have to change something, an input file someplace. Is there a cell that shows where to change the inputs that you're specifying?
It should be in your XML file.
Mhm.
XML.
But is there a, so Alex, you've done this, is there a cell in the notebook that says change these to your new data set and then?
No, I don't think
Okay.
there's actually a cell that says that.
I see.
This file.
Yeah, well, it's a little confusing because there's this one, and then there's a cell that basically copies this and moves it into another folder.
Okay.
So let's, can you scroll down, go up, I guess. There should be something that,
Yeah, so there's where it's configuring the inputs.
Mhm.
yeah, so reference XML and secondary XML, those are your XML, those are the files that point to, that have the names of the data files that you're going to be processing. So you have to change those. I thought that if you scroll back up a little bit, so it says configure inputs. Here you go.
Okay.
There you go. So you see, scroll back up a little bit.
Back.
Other
Okay.
way, other way.
Other way. Okay.
Yeah, right there, right there. Oh, stop there. So you see reference XML and secondary XML.
Yeah. Yeah.
These files have to be changed to point to your data that you just downloaded.
Yeah. Okay. Okay. I understand. Okay.
And I think the place to do that is up in basically step 0 of the notebook, initial setup of the notebook, that configure inputs function is defined. And I think that would be the place to change.
So can you scroll up to the top where configure inputs is defined?
Yeah. Okay. Configure. Okay. I think it's down. I think.
Is it? I think it's used further down, but
Yeah, I think it's
was
done.
that it?
Um,
Let's see. I can probably find it.
okay, but I understand. I will search about it. Okay.
Okay,
Okay, I will search about it and try to change it. Okay. Thank you.
Hello, everybody. I kind of have a follow-up question on that because I had the same issue. And I went and I changed my XML files with the correct information and changed the area of interest. And it's still at that cell 3.1. It's still just trying to pull the old data and the old files. And I guess my question was, after not being able to figure out where else I could change the info to the new Sentinel-1 files, should I be like creating a completely new directory every time I run this programming? Because I have old files in there. I just kind of ran it again, and I was thinking maybe it's getting stuck just because it sees those.
I think my general advice is when you're doing a new run, always do it in a new directory. It keeps things kind of simple
Okay.
and clean. Because yeah, some of these programs will look for a file of a certain type, and if they see it already there, they won't recreate it.
Okay, yeah, maybe that's the case. And so so the only thing I need to copy into the new directory is the tops app. And then it'll create it, well, because it creates the inside directory during the run. So that should be the only thing, right?
I believe that's correct, but I'm not incredibly familiar with this notebook.
You also need the load orbits script.
Oh yeah, the load orbit script. Okay, awesome. Yeah, I might as well just do that and give it a whirl.
Mhm. And one thing I tend to do too is I think it's often easier to change the name of the run I just did to something else and then leave the names of all the directories in the notebook itself the same. So if you, I can't remember what the name of this top level directory where you're doing all the processing is, but let's assume it's data. So instead of creating a new folder called data2 and then changing all the lines in the notebook to use folder data2, I'd instead change the name of the folder where I just did the run to like data_run1. And then
Okay.
the next time I run it, the folder would still just be named data. And that kind of makes it so you
Okay.
don't have to go around changing directory names all the time. But
Yeah,
I think that's a personal preference.
sure. Cool. Thank you.
I did find that the definition of configure inputs is the second cell or at the top, and all of the files are hard coded there. So as soon as you run that, it will it'll change everything in your XML file to the original test data set.
Good to know.
And where is this hard coded again, Alex?
I think it's second, they're very big, but I think it's technically the second cell at the very top.
Yeah. So the definition configure inputs.
Yeah, so you'll see everything, including the region of interest, and the files are all hard coded there.
Okay, so if I just change that to my files, yeah, and I didn't change that one. So yeah, thanks. Good catch.
I did have a question, if anyone knows when the region of interest is incorporated, at what step in the TOPS processing does it subset?
Paul can correct me if I'm wrong about this, but I think the region of interest is used to grab the specific bursts that overlap that region. So at the step, let me see. what that would be.
The reason I asked is because a few of us had this issue where we made a new area and it, everything, the files are right, but it says it can't extract swath 3, for example, but 1 or 2 would work. And so I don't know if that's because it's already subsetting and therefore maybe your subset doesn't include swath 3, or if it could be a different issue.
I think that could be right.
Okay.
Yeah, because I think even the DEM download step will depend on your region of interest.
Okay. And the swaths are 1, 2, 3 is from near to far range. Is that correct?
Yeah.
Yes.
One thing about the region of interest, it's going to take all the bursts that touches the region of interest. So not necessarily just crop them to that subset,
Okay.
but it will pick, so your interprogram might look different than what you were expecting it to look in terms of like its shape.
Yeah, I'd noticed that. Okay, thank you.
I have another follow-up on that that I was just curious about last night. So for the test case that was given, we were only looking at, I think, swath 3. And is that just because our region of interest was defined to incorporate bursts from swath 3, or is that defined somewhere? I couldn't find anywhere where that was defined.
I think it's defined right where the region of interest is specified. There was a,
Oh,
Right.
swath, yeah, swath 3. Okay, yeah, I'm staring it right in my face. Okay.
I do that a lot.
Yeah, so sometimes you look at things and you just don't see what you need to see.
Yeah, I think they picked one swath because that's where the earthquake is and it's faster to process one swath than all 3.
Okay, and so that's that property name equals swaths, and then there's the 3.
Right.
So if I just put 1, 2, 3, is that all the swaths then?
That's it.
Cool.
1, I think it's 1, 2, 3.
Cool. Awesome. Thanks, Paul.
You can try it, see what happens. Come back an hour or 2 later.
See if we can crash OSL.
It's been quite reliable, I found, for the last.
Yeah.
Getting better at this stuff.
Yeah, it's great that OSL or something like it exists for this course, because it'd be difficult to set up these environments and ensure they all work and everything.
Yeah, I think the first time we tried a cloud version of this with UNAVCO was, I want to say 2016, before OSL existed. And it was a challenge.
Well,
Correct.
before that, the INSAR courses were first day installation problems kind of approach.
We tried to pre-configure all the laptops, but everybody wanted to bring their own laptop and do the work themselves. So it was, not optimal, that's for sure. The software was pretty flaky too. Much better.
So I have another question if there's time here. So there's an additional XML file in the INSAR directory called tops processing. And I'm just pulling it up. So this gets created automatically based on the settings you want for your tops run. Is that correct?
I believe so.
Okay.
Is that the topset.xml?
I know it's the tops pros.xml. So it's in the same directory and it gets created a little bit further along in the process.
It's in under the inside directory, topsproc.xml.
Yep, that's the one.
I'm just looking at it now.
So yeah, it didn't seem to have a ton of like useful information in it.
It seems to be an output. I seem to remember this being an output.
Okay, this is an output. Okay.
Tells you the width and length of the burst, number of bursts, the name of the secondary and reference. Yeah, this looks kind of like an output to me.
Cool.
Some of these questions that were a little fuzzy, and none of us are, I didn't write this notebook, I just use it, and I don't use it that much myself. So at 10 o'clock, when Eric's back on, I'm sure if these are lingering important questions, you can just ask them again. It defeats the purpose of office hours, I suppose, but we're doing our best.
You're doing great. So thanks.
We all have different strengths. But I'm pretty sure I'm right about the top spot. Definitely looks like output.
And just an update, so changing that second code block. Now I'm actually processing the files that I intended to. So good fix.
You can
Great.
also programmatically change the directories. I saw in the top of the notebook. It specifies all the directories, so you can change the path to that to move everything to a different area within the notebook. So I think it's in the very first cell. It specifies the paths to all the directories. So you could change tutorial home dir or something, or put an extra. Instead of calling it data and SLC, you can call, put some other path in there. Silence usually means people don't know what I'm talking about, so I'm gonna. Yes. I think you can just change these, either call this data, instead of calling it data, which puts it right below the tutorial home dir, you could probably specify here a relative path, like if you wanted, instead of sticking this in, you could probably do an absolute path here, like home, Jovian, stupid name, data, for all of these things, and it would then put it all in a different place. I think, although this is a join thing, so maybe this has to be relative. Might have to be relative. So do // something you can play with to set up the paths. So it takes tutorial home, it goes up one level and creates a data directory, or you could go up 2 levels and create a data directory, go down to a new one, date 1. I'm just making this up, date 2. Just create your own path so that it doesn't write it right in this tutorial area. Okay. Let's see the thumbs up. Well, it's 10 of the hour. I think I need to get ready to go to another meeting, so I think I'm going to drop off. I don't know if others want to stay till the end of the hour, but I'll see you all at 10. Talk to you later.
Bye, Paul.
Bye.
I can hang around until the end of the hour if there are any more lingering questions.
Forrest, I need to head out for another meeting soon as well. So
Sure.
Thank you. And
Yep.
see you later.
See you later.
Yeah, thanks as well. We'll see you in an hour or so. Or 2 hours.
Mhm.
Well, I have one question to ask. It's not really related to the notebooks, but like I remember in the first day, Franz said that one of the goals of this course is that we will be able to process data more on the cloud. And this is for NISAR because there will be much more data to process and it will be much easier to do this in the cloud. So will you provide with NISAR like more resources or more access to OpenSR Lab, or will be like another platform, or this will be the platform where will be able to process the data?
So it all kind of depends how much funding there is available for OSL. OSL is through the Alaska Satellite Facility, and it's been something we've been growing and been really exciting about. But at the end of the day, running computation costs money. So as long as we can get money to provide this platform to people, I know that it is our hope that we can distribute it widely. I know also the OpenSR Lab team offers help for people who want to get their own version of OpenSR Lab running. You know, the whole infrastructure and everything is open source, so you can take it and move it into your own cloud account if you choose to as well. And if there isn't funding available to just stand OpenSR Lab up for people generally, that'll probably be the route that this thing will go.
But so far there is no plan for this, because I thought this is like part of the plan with NISAR there, so there should be, or there will be like more access, more resources, so that we'll be able to do everything more faster on the cloud. This is just what I thought.
So I'm not as high up in the NISAR chain of command. I'm more on the outside of it. So that might be a good question to ask Paul during the NISAR question as well. But my understanding is that the way that like more cloud processing is going to happen is that the NISAR products will actually be processed too much farther down the tool chain or the processing chain than right now, like Sentinel-1 data is. So I think, for instance, they're hoping to offer a deformation time series product for NISAR, which means you don't, if you're just interested in, you know, monitoring deformation over time of a certain area, you don't have to go through, create your own interferograms, ingest them into MinPy and run an analysis and then look at the data. You can just start from a deformation time series.
Okay.
And I believe that's the context in which they're hoping to do like more cloud processing. But I don't know if they're planning to offer basically like a cloud processing playground or basically platform to do analyses with Opera data.
Yeah. So it's like what we are doing with Hive 3. Like there's the on-demand request, if you have something that you wanna process, you ask for it and just you get it same way.
That's what I believe they're hoping to do.
Mhm.
Have you checked out or heard of the Opera project at all?
I should do what? Sorry.
Have you heard of the Opera project?
No.
It's another great project out of JPL. Let me find the link for
Yeah.
that for you. But basically the hope for that is to start to provide these sorts of deformation products for people already processed. For Sentinel-1 data, so you don't have to go back and do this all yourself, much like height. I think right now the Opera project is going to be limited to North America, but over here at ASF, we're hoping that we might be able to extend some of the products that Opera is creating and provide those on demand to people if funding allows.
Yeah. This is okay. I'll go through this Opera.
Yeah, I think a good place to check out is they have a products page and they talk about what they're hoping to offer. So
So
hoping to,
it's not trying right now. It's like working on it, or there could be a way to ask for data processing and stuff.
I believe they're actively processing it right now, and they already know which areas they're going to be looking at. I just sent another link, which is just like a page on that website. And if you scroll about halfway down, they have a table where they say what products they're hoping to offer and roughly when they're hoping those will be available. So for instance, a Sentinel-1 A and B displacement product, similar to what you would get after you finished processing with MidPy, they're hoping to have that by the end of November 2024. So if you're hoping to do research right now, I probably wouldn't wait around for it, but
yeah.
Along the line, it could become available.
Yeah. Actually, it's good to have like different products working on this. It will be, more options to have. Yeah, sure.
Yeah, that's right. I think the exciting one here is actually they're talking about offering a co-registered SLC product by the end of September 2023. And that product is going to be really fun and interesting because it's already done all of the hard co-registration stuff, the things that take forever. And then from that, you can start using, you can make interferograms very easily on top of a CSLC without having to go through probably like 9 of the 10 steps in this TopSap notebook. Let me see, so if you're working with a CSLC instead of the normal SLCs that we work with, you probably, so basically that product, if you're looking at the TopSap notebook, you would be starting from step 3.7 as opposed to step 1. So all you'd have to do is, if you wanted to apply a ionic phase screen, you can do that. And then you're just forming your interferogram and doing some merging and phase unwrapping. So that's going to be a really cool product when it comes out, and it's going to be coming out a lot sooner.
Yeah, but the product, the format of the product, I'd be able to process it on like what software, or that's the same way, complete the same process that we are doing.
Probably it would hook into, I'm guessing they might have it work. I'm not sure, once again, I'm not on the Opera project, but I think they're either hoping to make it compatible with either ISCE2 or ISCE3.
Yeah.
So one of these two. And then, at the point where you're working with a co-registered SLC, most of the hard, very, very SAR specific stuff is done-ish. So you could also write your own set of scripts to do this in Python, probably. Python is kind of the main programming language where most of this INSAR stuff happens.
Okay, that's good. Okay, thanks, Phil.
Yeah, no problem.
Forrest, we're about 1 minute to the top of the hour. Do we want to just go ahead and call it?
Yep, I think so.
All right. Well, we'll see everybody that's maybe still on at 10 o'clock
Yep, see
time
you.
for the lectures. Bye.